All right, so picking up where we left off, the problem said determine whether the graph of x equal to y squared minus 1 is symmetric to the y-axis, the x-axis, or the origin. So we saw that if I want to test whether it's symmetric to the y-axis, I will substitute in negative x for x. If I get back the original equation, then that means it is symmetric to the y-axis. So when I plug in negative x for x, I wanted to do a clean comparison to what I originally had. So I made sure that I multiply both sides by -1 to get to, so I can say x equal 2 and see what x is equal to. Once I multiplied both sides by -1, I saw that I had negative y squared plus 1, which is not what I originally had. So since this is not the original equation or the original function, it is not symmetric with respect to the y-axis. So now we want to check symmetry to the x-axis, and that means we'll substitute in negative y for y and see what we get. So that's negative y squared minus 1. Squaring negative y is the same thing as, well, negative times negative is positive. I'll say it like that. So this is what we have. Compare that to your original equation. That is exactly what we had. So since this function is the same as the original, it is symmetric with respect to to the x-axis, excuse me. All right, and then finally we want to check symmetry with respect to the origin. And in order to do that, we will substitute negative x for x and negative y for y. So we have to do both in order to establish whether it is symmetric with respect to the origin. So plugging in negative x, plugging in negative y. So once again, negative y squared is just y squared when you simplify it as much as possible. And multiply both sides by -1. That'll be x equal to negative y squared plus 1. And remember our original equation was x equal to y squared minus 1. And it goes back to All right, so since this function is not the original function, it is not symmetric with respect to the origin. All right, questions. All right, so even in odd functions, if when you plug in negative x, you get the original function, it's an even function. If when you plug in negative x, all of your signs are opposite the original function, then you have an odd function. All right, so the next exercise, determine whether it's even, odd, or neither. All right, so first function, f of x is equal to x cubed minus 6x. So we're going to plug in negative x into the function. So don't forget the effects of an odd power versus an even power, and that's where this even and odd terminology even comes from. Negative 1 squared, that's negative 1 times negative 1, is going to be a positive 1. Negative 1 cubed, negative 1 times negative 1 times negative 1 is going to still be a negative 1 because of the odd number of negatives. You'll always have one left. So that will always be the case when it comes to even and odd power. So if I have a negative 1 raised to 400, that's still going to be positive 1. If I have a negative 1 raised to 505, that's still going to be negative 1. All right, because there always will be a negative left after your cancellation. Negative to negative turns positive. So when I look at what's going on here, negative x cubed is going to reduce to negative x cubed because we have an odd power and there's going to be a negative left. And then over here, negative 6 times negative x will be a positive 6x. All right. All right, so each one of our signs are opposite the original function, so that means it is odd. All right, so g of x is equal to x to the fourth minus 2x squared. We'll do the same thing, plugging in negative x. All right, so this even power allows the negative to cancel out completely, giving me x to the fourth. Same thing with the x squared, the negative x squared. All right, so this function is the same as the original, so that means it is even. All right, questions. All right, so do the same thing and then check your result. Negative x squared cancels out the negative, but then here, that's going to be a minus 2x. So we got x squared minus 2x plus 1. So this one, um, all right, so all signs are not the same, neither are all signs opposite. So this function is not even or odd. All right, questions on even and odd functions. Okay, let's look at the next thing. All right, so the last thing out of this section is your difference quotient, f of x plus h minus f of x over h. So this is something that you will use more in calculus. They just want to expose you to it right now, so it's not the first time that you've seen it. All we're going to do is find the difference quotient, but you will not be applying it. You can use something like this for finding the slope, finding the tangent line, all good stuff like that. But like I said, that's calculus work. This is just exposure to it.
So will we have problems like this on the homework, sir?
I'm about to show you what the problem will look like now. Yep.
Okay.
Okay, so they'll give you a function and then ask you to find the difference quotient. But like I said, outside of that, though, they're not going to ask you to do anything extra with it. So let's go ahead and do that. F of x is equal to 2x squared minus x plus 3. And it wants to find the difference quotient. So if you look at this formula, the way it's set up, you need f of x and f of x plus h. We already have f of x, which is right here. What we need is f of x plus h. All right, so let's find that. And we'll find that by plugging in x plus h into our function. Everywhere we see x, we are going to put x plus h. All right. And don't forget, you need to expand this out. That's x plus h times x plus h. All right. And don't forget to do your full x squared, xh, xh, h squared. I don't need the parentheses really. Yeah, I do. And combine your like terms, x squared plus 2xh plus h squared. So that's that expansion. Also, you can distribute that negative. So before I go any further, make sure we're okay. All I did was FOIL out that x plus h squared and distribute the negative. So make sure we're okay before we go any further. All right. So the next move is to distribute this 2. So that's 2x squared plus 4xh plus 4h squared minus x minus h plus 3. So this piece right here, or this expansion, is your f of x plus h. Oh, whoa, that's not supposed to be a 4. I put a 4 by mistake. Should be a 2. All right, so don't forget what the formula is. F of x plus h minus f of x over h. So 2x squared plus 4xh plus 2h squared minus x minus h plus 3. That part is f of x plus h minus 2x squared plus h plus x minus x, excuse me, plus 3. That's f of x. It's all of h. All right. So before I combine my like terms, this minus sign needs to probably go green. This minus sign needs to affect each one of those terms. So even if you don't write it out, that's how you should be processing what's going on. So that's a negative 2x squared plus x minus 3. Now we can cancel out like terms. We have 2x squared, that will cancel. X, that will cancel. Also 3, that will cancel. And what is left is 4xh plus 2h squared minus h over h. There's a 3. There are two 3's here. There's a 3 right here and a 3 right here. So 3 minus 3 will cancel out for us. All right. All right, so each term left after your cancellation must have an h in it. All right. What allows, or what happens next is that this h has to divide into each term under there. So if you do not have an h in each one of your terms, and somewhere you may have miscalculated or missed a term to cancel out, something happened because each term should have an h in it that's left. All right, so h is canceled. One of these h's cancel, and this cancels as well, leaving you with 1. So your difference quotient will be 4x plus 2h minus 1. All right, questions on that? All right, so let's do one more just to make sure we get the gist of what we should be doing. This one's a little shorter, but still emphasizing the point. So we have f of x is equal to 3x plus 7. I want to know what is f of x plus h. So I'll plug in x plus h wherever I see x. Expand it out as much as possible. Here, all we have is a distribution of 3. The formula f of x plus h minus f of x over h. So that's 3x plus 3h plus 7 minus 3x plus 7 over h. So once again, this right here is f of x plus h. This right here would be your f of x. Let me know if you have any questions before we keep moving. So, has everyone done the test? I'm just trying to see how. Nope, everyone has not done the test. But some, you got a little time, but you don't want to just to be honest. You don't want to gauge yourself upon everybody else. You want to gauge yourself upon the lectures. This is 2.2, second section out of chapter 2. So what you don't want to do is find yourself so much into chapter 2 that we're about to close out chapter 2 and you're still messing with chapter 1 stuff. So that's really pretty much how you want to gauge yourself. Making sure that you're trying to stay with the lectures because you don't want us to get too far, or you want me, put it like that, you don't want me to get too far away from where you are in your homeworks. So that's how I would more so look at it. Mhm. Not a problem, not a problem. So I'm gonna go ahead and distribute this negative. And so that'd be 3x plus 3h plus 7 minus 3x minus 7 all over h. Cancel out like terms. 3x minus 3x cancels. 7 minus 7 will cancel as well. This one leaves us with 3h over h. Our h's cancel, and we're left with just 3. All right. Any questions before we step into 2.3? Probably won't finish it, but at least we'll start it. All right. As a matter of fact, let me do this. Make more. Okay. Oh, no, before I start talking, let me say this too. All right. So your slope, we're going to use M to represent our slope. So just in case you haven't seen or messed with slope in a while, it's y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2. It doesn't matter which one you use as long as you stay consistent with what comes first, whether it be y2 first on top, then that means you need to use x2 first on bottom, or if you use y1 first on top, use x1 first on bottom. Oh, no problem. You're fine. You're fine. So also, rise over run is a relationship that needs to be considered when you're dealing with slope, but we will use that when we go to graph. So x1, y1, and x2, y2 are or will represent any points on the line. Any 2 points on the line will calculate your slope for you. Um, and x1, y1 would be what you would be calling point one. X2, y2 is what you would be calling point two. All right. So, and then your slope is just the incline of the line, putting a number on the steepness of your line, like the slope of a mountain, slope of your roof, something of that nature, slope of a ramp. That's all it is putting a number on it and direction as well. And you'll see what I mean in a second. All right. So we're going to find the slope of the line passing through the points -3, -1, and -2, 4. So I'm going to do it both ways for this first one, just to show you that either way will give you the same result. But after that, just keep in mind that all you have to do is do it one way. And like I said, either way, you'll get the same result. So I'm going to call this first point x1, y1. Second point x2, y2. All right. So we got y2 minus y1 over x2 minus x1. Y2 is 4. Y1 is -1. Make sure you don't lose a negative. A lot of people make that mistake. So we substituted in -1, but there also was a negative or minus sign in your formula. X2 is -2, and then x1 is -3. Negative to a negative turns positive. So that's 4 plus 1 over -2 plus 3. That will be 5 over 1. Your slope is 5. All right, any questions? All right, same problem, but this time I'm going to let y1 be first and x1 be first. So y1 is -1, y2 is 4, x1 is -3, and x2 is -2. On top, I have -5. Bottom, that will be -1 because that's -3 plus 2. And result would be a +5. -5 over -1 is +5. All right, questions. All right, so one more just to make sure we're good. -3, 4, and 2, -2. So label your points, point 1 and point 2. All right, y2 minus y1 over x2 minus x1. Y2 is -2 minus y1, which is 4. X2 is 2 minus -3. On top, we have -6. On bottom, because of that negative negative, which is a positive, that would be a 5. And there's your slope. Okay. Well, before I do that, sorry about that. That's next. Let me do basic behaviors first. All right, so your four basic behaviors of your slopes. If you follow your graph and it's going up or increasing, like this one, following it from left to right, that means your slope is positive. If you're following your graph from left to right and it's going down or decreasing, like this one, that means your slope is negative. We wrote that purple better. Not the purple, but the VE is negative. If you have a horizontal line, your slope is 0. If you have a vertical line, your slope is undefined. So those are your four basic behaviors of your graph. And you always follow your graph from left to right. All right, so graphing using your slopes. Mentioned before that that would be rise over run horse. Your rise is going to be up or down. Your run will be right or left. So what dictates what direction we go will be dependent upon whether we have a positive or negative number. Your positive moves are up and right. Your negative moves are down and left. So, matter of fact, this. So, for an example, if I had positive 2 over positive 3, it means I will go up 2 and right 3. Or if I had negative 10 over 7, and that negative cannot go to the top and bottom because remember, negative over negative is positive. So you make a decision which one you want to give it to, either give it to the top or give it to the bottom. I normally say just give it to the top and be done with it, but if I decide to give it to the top, that's negative 10 over 7. So it means I go down 10, right 7. Or if I decide to have give the negative to the bottom, that means I will have a positive 10 over negative 7. That means I will go up 10 and then left 7. And either way, you will get the same line. If I'm starting here at this point and I go down 10, right 7, or if I start at this point and go up 10, left 7, either way, I'll still have that same line. You just have to remember to give that negative to either or and not both. All right, any questions? All right, one more thing before we use that. All right. So your slope-intercept form, y equal to mx plus b, where the number that's in front of x is your slope, and the other number that's not attached to x is your y-intercept. So if I have y equal to 2/3 x minus 1, and notice it's, this linear equation is in slope-intercept form where your equation is solved for y and simplified as much as possible. So if you have that, then that means it's in slope-intercept form. The number that's in front of x is your slope. Your slope is not 2/3 x. So sometimes a lot of people like to include the x as a part of your slope, but that's not the case. That will be considered wrong. Your slope is not 2/3 x. Your slope is just the 2/3. And then your y-intercept is the other number, which is -1. All right. Same things if I had y equal to -4x plus 3. Slope is -4. Your y-intercept is 3. All right, so let's use that information to graph. We can take that y 2/3 x minus 1, y equal to 2/3 x minus 1. We already established that our slope is 2/3 and our y-intercept is -1. So if that's +2 over +3, that means I go up 2, right 3. Now the coordinates of your y-intercept, normally they set us up to talk about intercepts before we get to slopes, but this one actually talks about it afterwards, so we'll get there. But the coordinates of your y-intercept will always have x as 0. So when you go to graph your y-intercept, x is always 0. Let's see, use the slope. All right, so 2 steps. You're going to graph the y-intercept first, and then we're going to use the slope to generate another point from the y-intercept. So a lot of people make that mistake right there, trying to graph using your slopes. Your slope is not a point, so you cannot go back to the origin. Your slope is just directions of how the line behaves. So what you would do is graph a point that you know is on the line, then generate another point using the slope information. All right, so we're going to graph the y-intercept first. So 0, -1 is right here. Go nowhere for x and down 1. Then from your y-intercept, we're going to go up 2, right 3. And that's your line. All right, questions before we do another one? Make sure we're okay with the process. All right, same type of deal. My slope is -5. My y-intercept is 4. As a fraction, the slope is going to be -5 over 1. So I will go down 5, right 1. Then as an ordered pair, y-intercept is going to be 0, 4. Once again, x is always 0. All right. So we can graph this. First, we will graph the y-intercept, which is 0, 4. So nowhere for x, but up 4. And then from the y-intercept, you go down 5 and then right 1. And that's your line. Questions, questions, questions. How do we get to 1? Oh, as a fraction, any number, if I had 100, any number would be as a fraction as that number over 1. So, yeah, just understood that if you see a solid number, you can put a 1 under it to make it a fraction. Yeah, not a problem, not a problem. All right, so your point slope formula, you could use any point on the line and the slope to find the equation of the line if you use this formula. Y minus y1 equal to m times x minus x1. right, so this will probably be the last one for the day. Write an equation of the line that passes through -1, 3 with a slope of 4. So my slope is 4. And x1, y1 is -1, 3. So the formula y minus y1 equal to m times x minus x1. We are plugging in for these three values, y1, m, and x1. Don't forget y and x is supposed to still be a part of your equation. So y1 is 3, m is 4, x1 is -1. Make sure you don't lose negatives when you go through your substitution. So that's y minus 3. Negative to a negative turns positive. Also, I need to distribute this 4. So that's 4 plus 4. That should be 4x plus 4, excuse me. And I can finish it off by subtracting, adding 3 to both sides. Y is equal to 4x plus 7. All right. Questions? Any questions, concerns, comments on anything? All right. So on next class, we will pick up right here. A few more things in 2.3 we need to finish out before we leave it. So just like any other time, make sure you get with me on questions if you have them before Monday, before Monday, if you want me to answer them before then, or you can bring them to class. We can talk about them in class. Zoom sessions, outside of class are available to you. Just let me know. Outside of that, you guys have a great weekend. Be safe, and I will see you on next class.